Okay, so the right, this is the question. Okay, so Ayush has asked that what estimation techniques have been used for estimating the demand of energy constraints and the principles used in aggregate modeling to share, if possible, detailed methodology adopted for this. So this is in week 12, and in week 12, I had just indicated to you, I had shown you only some of the results. So if you see, for instance, if you look at this is the result which was shown from the IEA for the World Energy Outlook. In most of these situations, the uh, International Energy Agency, or in some cases the IPCC, use a whole host of models. These are models with regional uh, equilibrium and estimation of the economic GDP, and then some kind of an optimization and different types of scenarios. Most of these have two or three scenarios. They have a baseline scenario where you have a business as usual, then they have a scenario where you have a high energy efficiency, and in a third scenario where you're looking at, in this case, they have a sustainable energy scenario. So they actually show, for instance, in this particular case, they have a scenario where if you had the current growth, this is how it would be growing. And then they show that if you do all the policies that each of the countries is adopting, how much would be the reduction in the CO2 emissions. And then they identify, if you really want to go for deep decarbonization with the sustainable development scenario, there are a whole host of different methods. And this has a combination of energy efficiency and renewables. In all of this, there are, for if you are interested and you can post on the forum, I can send you links uh, which provide details of the kind of models used in many of these cases. IPCC has a separate report on sustainable emission scenarios. Each of the scenarios is detailed, the methodology explained, and the modeling tools also explained. So this will be in our course. We have just given a sort of brief glimpse of it. So Ayush, is that going to answer your question, or do you have any other question related to this? Ayush? So the question that was asked, so this was the first question. The second was, uh, can renewable energy overcome the duck curve syndrome without the use of storage? So essentially what happens is, if you look at the duck curve syndrome, the basic thing which happens is, if you have a supply mix with a large amount of solar photovoltaics in it, then during the evening, when the PV goes down, then suddenly there is a drop in the demand, and there is a drop in the supply, and that has to be met by the rest of it. So the net aggregate requirement, which is to be supplied by thermal and the other sources in the system, has to suddenly ramp up, and this shows basically like a duck curve. The way in which we can overcome this is if we had uh, storage, or if we have uh, hydro which can suddenly ramp up. Uh, can renewables overcome this? Well, the only dispatchable renewable that we know of is biomass. And we could have biomass, and we could also hybridize renewables. That means if you can have biomass which can be stored along with the solar, and that biomass can be ramped up. But typically, demand response could also be used. But usually, this can be only planned with the use of either having more flexibility in the way we run our thermal plants, or by using biomass, or by using storage. And hydro, of course, can provide a solution. Pumped hydro can be used as a storage. That means you have a reservoir which is at a high level and you have a reservoir at a low level, and whenever you have surplus power you pump up to the high level. When you need certain more electricity to come, you take it from the high level reservoir to the low level reservoir. So are there any other related questions? Ayush, do you have any other related question on this? Aggregate model for energy modeling for projection by 2040. Link of the study. Okay, I understand. So you were asking basically about the Niti Aayog study. The model, uh, the Niti Aayog 2047, the energy secure IESS, this is called. I will post the link on this on the website. The IESS is a web-based model, and it uses basically an Excel-based format. It has different levels of demand, and for each level of demand, it estimates what is the kind of energy requirement. 2012 was used as a base year, and this has been projected into the future. So this is a very simple kind of model which you can play around with. They also had an Excel version which was downloadable, but I think it's not now available on their site. But a web-based version is currently available, and I will send out a link to the Niti Aayog study for that. Is that all right? Ayush, do you have any other questions related to that? When we'll go to a second question after this. Is this okay, Ayush? Okay. So let the next question that you have is, can indifference curves be upward sloping in some cases? So if you look at indifference curves, if we are talking of utility of two goods, both are goods, not a good and a bad, then what will happen is that you have two things which is there, that more of any good is always better, because we have monotonicity and we said that there is no satiation. There's also we had the marginal rate of substitution. So if these two um, trends of indifference curves are to be taken, then indifference curves will not be upward sloping, they will only be downward sloping. uh, the you will see, if you just search on the web, you will find some cases where people have taken one good and one bad, in which case then of course it could be upward sloping, because you want less of the bad and you want more of the good. But if you are talking of two goods, then it will not be upward sloping. So indifference curves would not be upward sloping based on the definition that we have of the utility uh, and the preferences, where there is non-satiation and there is monotonicity. That means more of a good is always better. Okay, let's move on to someone else. Okay, who are the other people who would like to ask questions? If you can just, on the chat, if you can just put your name. If you have already put the questions, I can pick up those questions. Otherwise, you can just put the question on the chat. I have listed down some of the questions here, but I'm not sure who has, I didn't put down the names of the people. So
What's the leading hour?
anyone who's on the chat who wants to ask any question? Uh, Okay, so this is a question from Hamza Siddiqui. What is the most suitable resource that can be used for supplying base load in the upcoming years? But this is a tricky question to answer. Uh, as of now, it's been basically we've been talking of coal and nuclear as base load. We may think, if you think in terms of renewable, this is something where we can think in terms of biomass being a base load. And the whole concept of base load and peak load is also changing, because now what is happening is that the peak of supply is will happen during the day. The peak is required of the demand is in the night. So actually the daytime is where we will have surplus capacity, so the whole rules of the game will change. And in terms of dispatchable renewables, it is possibly we can think in terms of biomass. We can also think in terms of hybrid systems, where we are looking at a multiplicity of renewables which is there. Anyone else? Any other question, Hamza? Any other question? Okay, so here this is the question here: how does fuel cell compare with batteries in terms of large scale energy storage? So one of the things that we need to understand is that both fuel cells and batteries are electrochemical devices. And though a fuel cell is not a storage device, a fuel cell is an energy conversion device. So the moment we discontinue the fuel and the oxidant to the fuel cell, the output will change, will stop. And a battery, again, if you are looking at a primary battery or in a secondary battery, you would have a particular amount of capacity, and it is basically which is known as a storage battery. The comparison of fuel cells and batteries, again, a fuel cell coupled with an electrolyzer can perform the role of a storage, because we can reverse the fuel cell. It can be used, and then if you can decouple it and store out the hydrogen and oxygen, let's say, and then bring it back, then it could perform, a fuel cell and an electrolyzer could perform a function of a storage in the grid. Right now, and both fuel cells uh, are, the problem is the life of the electrodes and the cost. And but fuel cells uh, can have a greater role in the future energy systems. In terms of large scale energy storage, if you think in terms of fuel cell and electrolyzer, as well as some storage for the hydrogen, with hydrogen storage, this has been tried out in sort of demo plants, but they are nowhere near commercialization today. In the case of batteries, we have some large scale lithium ion batteries being put in Australia, and also in India. There has been a pilot study, but today also this still adds a reasonable amount to the cost, and we have to wait and see how the technology develops to see which one is going to compete. Any other caller who wants to ask? Anyone else who's on the chat who would like to ask a question? So this is a question which I think some people have in mind some tips for the final exam and what will be the pattern of the paper. The final exam is relatively quite simple. So if you just go through the videos and the assignments, I think you should be fine with it. We will have some multiple answer questions as well as a few where you have to do the calculations. We will also give you a formula sheet so that you don't have to remember anything in terms of formulae. But there will be some simple calculations and about probably about 60% will be multiple choice questions and some will be 40% will involve some calculations. But the questions are pegged at a level where if you have gone through the material and the content, you should really do well. It's not pegged at a very high, because we don't have the option of subjectively correcting. So actually, if you have gone through the material, you should definitely do well in the test. I'm not sure when the tests will be conducted, but that NPTEL will tell you once it is safe for everyone, and then they will work out that for you. Okay, there were some questions which I think may be of interest to some of you. I do not know whether the person who's asked the question is on the call. Um what impact would the OPEC production cut have on renewable energy? And what impact would the COVID-19 lockdown have on renewables? There was also another similar question I thought, yes, in view of current economic turmoil due to COVID, what would be the potential impact on the energy sector? Okay, so the exam will be computer-based online exam. That is right. The question which was just asked by, yeah. So let's look at this. I've see if you look at the COVID-19 situation is completely unprecedented. It is completely changing the way countries and the world are going to do a variety of things. What you would see immediately is that this has had an impact because almost the entire world is under lockdown, and of course there is an impact immediately in terms of the energy demand. So if you see the energy demand, this is, you can look at this from the POSOCO website. Can you see this plot? This shows the comparison of the all India demand. These this data which you see here is the all India demand for 2020, and this is the 2019 number. So you can very clearly see that there is a significant drop in the demand. And of course, this is because of the lockdown. The shape of the demand would have also changed. Most of the industries are shut down. But as even after it improves, we will still have a residual effect. So one of the key things which is going to happen is, for the short term, for a couple of years, we may have surplus capacity in our electricity power system. And we've had a way in which we have committed to generators. So then those generators will not be dispatched. They will ask for their payments. And so there will be a situation where either the government has to bail out or some companies will make losses, and this may get again translated to the customer. The second thing is there may be a problem in terms of supply chains. So, as you know, as we've discussed also, that a large proportion of our PV cells and modules have been coming from China. So those supply chains have been disrupted, but it looks like China is sort of bouncing back. But those are one of the supply chains as well as the site work. All of this will get affected. In the long run, this may uh, convince governments to start focusing more on indigenous capability. Of course, this we have to see and it will all depend on how the dynamics plays out. We may have more industry. The government is hoping that some of the industry from China will actually shift, and we will have more manufacturing in India. They are talking of Vietnam being a site where manufacturing will happen. So the whole dynamics of the world may get transformed, and it will depend on the way that we look at imports and exports. And but definitely we will rethink many of these. The other issue that we can see very clearly is that despite whatever we think in terms of our technology, in many situations we are really helpless when it comes to some kind of a natural emergency. And so when you look at the climate, we also do not know when will that tipping point occur. Today, because of the lockdown, most parts of the world we have much better air quality, much lower emissions, and we have also discovered that there are many jobs that we can actually do where we work from home quite efficiently. The transport, the tourism industry is of course going to be uh, hit very badly. Air travel again is going to be affected very significantly for large periods of time, and we are not sure whether we will get back to the same kind of equilibrium. So it's a little tricky, difficult to understand exactly what will happen. But in the short term, I think there will be surplus capacity in our power systems, and this may affect initially growth of renewable energy, but it should finally taper off. The other thing which has happened is that oil prices have gone down very significantly. If you look at it, oil was at about $50 per barrel, and it went down to almost like 25, half of that, $25 per barrel, and then it has come up. So overall, for countries like India, where we have a large import bill, this will help initially in terms of our balance of payments. So you can also see on a different, on a day-to-day basis. Also, you can look at the comparison of the demand curve, and you will see that there have been some cases. For instance, if you look at the time when there was a we had this 9-minute shutdown. You can look at the POSOCO report on that. You can see that that 9-minute shutdown was managed very efficiently by using a large amount of hydro. Otherwise, suddenly ramping up and ramping down would be difficult. But the COVID crisis essentially tells us about the difficulties of making transitions, and also tells us that we need to be concerned about the natural equilibrium. So I think it may result in a rethink where people are more serious about trying to change usage patterns and trying to go back and look at uh, solutions for the climate change problem. Um, are there any other questions that anyone has? Anyone on the call? Are there questions which you would like me to answer? Anything else? Okay, so here's a question from Hamza Siddiqui. So is it possible in any way to convert a power plant to nuclear power plant, as some of the essential parts of both these power plants are the same? Yes, but the secondary cycle is more or less the same. But the problem in a nuclear power plant is that you need to have a large containment area. You need to have a problem. You need to make sure that the reactor is, so the location of a nuclear power plant and a coal power plant are usually different. And so this is something which theoretically it should be possible. Practically, it may not happen so much. We may convert, on the other hand, you can convert coal-based power plants to biomass-based power. We could also convert them to solar thermal-based power. And we can think in terms of repowering and using the same facilities and using the same land. Okay, Arushi. Okay, any other questions? So this, I don't think the person who asked this question is on the call. There's guidelines for doing LCA analysis of biofuels, in particularly biodiesel and produced from edible non-edible oil. So there is already a methodology for LCA analysis, and I have also shared with you a method where we looked at the um, biofuels. Uh, the critical thing in the case of biofuels, let me just see if I can find the slide. So in the biofuels, when we look at it, many cases it is possible that, yeah. So many cases what happens is it is possible that we may be using more energy into creating the biodiesel. So what happens is that depending on the area where we are doing the cultivation, the energy that is required for the cultivation, often this is being used because you don't want to have a problem in on food and fuel. We try to use this in wastelands. Now, in wastelands, if the yield is low and we have to put in too much of fertilizers, that will have an embodied energy content. So, the irrigation as well as the fertilizer, these become the energy input. Then there is a transportation and a conversion in the esterification, in the mechanism of creating the biodiesel. Again, there is an energy use. So when you look at it, there are situations where actually they could be, for instance, we had this Jatropa, and in the case of Jatropa, for some of the places, we found that the net energy ratio was less than one. That means we were putting in more energy than the amount that you are getting. And this is something that we need to assess, because many of these inputs are always subsidized. So it is always a good idea when you're looking at biofuels, to try and make this kind of assessment. So for instance, today in our country we have a lot of bioethanol, and you have some plants which have been made. It would be good to try and analyze these from an overall energy point of view, because you want to see whether or not they are net energy positive. So here is this question from Ravi Shankar: what are the sustainability factors included in various models? So typically what happens in models is we run different kinds of scenarios or possible what ifs, and in that, after you get the solution, for that solution you try and calculate what kind of, what is the emission, the global emissions, what are the local emissions, how much land is being used. So land, water, local emissions, global emissions, and any other kind of. So there are a whole, if you look at uh, sustainability software like Sima Pro, you will have a whole set of different indicators. So we can use some of these indicators and then try and see uh, whether or not that is sustainable. Any other questions? If there are no other questions, then I will close this interaction. Just wait for a few minutes. If you have any questions, you may either type them or you can speak up. Oh yeah, somewhere you're using the term with permission. What is the mode of permission? Okay. The World Energy Outlook creates annual energy report, the World Energy Outlook 2019, and I was one of the reviewers who reviewed it, so I have the permission to use the slides which they sent. They sent a slide deck, and they said you can use it. You should mention that it is used with the permission from the. So that's the method. Any other question or comment? Main challenges in terms of energy policy in India. But the policy, so we are a diverse country, and the policy challenges are both. We have to be able to look at sustainability, but we also have to see the whole issue of access and development and employment. So we cannot make a transition which is very costly, where a large number of people lose their livelihoods. So, for instance, if we you see when you look at uh, the renewables, almost all of it is in Gujarat, Tamil Nadu, in some of these states. The coal plants that they replace are in Chhattisgarh, Orissa, and they are in the east, uh, and a little bit in the center. So the different sets of people will lose their jobs, different sets of impacts on the economy, and we have to keep the human aspect in mind when we do these transitions. So that is why we have, in a variety of areas, we have subsidies, we have, so it is, energy is only a means to an end, and that is what has to be sort of looked at. We have very significant inequality within our country and a lot of diversity. So there are always flip sides of, you cannot theoretically make a policy which will impact everyone equally, and we need to be able to understand what kind of problems will be there. Would integrating more renewable energy sources in the grid make it more flexible and secure? Well, it all depends actually. Beyond a point, a higher share of renewables will need to have a different mode of grid interaction and operation, and we would need to have more storage and flexibility. We will need to operate our thermal plants in a different way. So actually, once we go to 30-40% or more share, then there will be a problem, especially if it is going to be mostly PV and wind, and we need to figure out ways to do this. There are, of course, technical solutions, but it all involves a certain amount of cost, and that's the tricky part. There's no very simple solution to this, and that's where someone had asked what is the scope for research. There, all of these are actually very good scope for. There is a lot of scope for research, for innovation, for technology development. Anything else? Anyone else have any questions? Questions, comments? Is there any region in India where transcos are using dynamic line rating methodology for dispatching? I am not aware of this. I can find out. You can just pose this question again on the interface. I'll have to get back to you on this. I'll have to check. There are lots of proposals in the power sector of having, um, even looking at creating short-term and dynamic markets. But with the current crisis, I think some of these things will be put on hold. Okay, I just ask any of our TAs, Santnam, Sarvesh, and Matrika. I'm not sure if Matrika is on the call. Aditya, if there's anything you want to say or add before we close the call.
I'd like to add one point. There was a question about comparing fuel cells and batteries. So there is one more challenge with fuel cells in the current technology is that when you convert electricity to hydrogen and then back to electricity, the round trip efficiency of fuel cells is quite low. It's less than 40%. While in batteries, that efficiency is around 85% with current technology. So that's one of the challenges that fuel cell also faces, is that I generate electricity, but when I store it and I get it back, I don't get the same amount of electricity back. That's just what I wanted to add.
Okay, thanks, Sanjana. Sir, anything you want to say? Okay, so we'll end the call unless anyone has any questions. Any other last comments? Okay, thank you all.